today we will have more activities and it's more challenging because I will, if I have a question, I will ask you. If no volunteers, no one raise their hands. If you raise your hands, you can obtain maybe 5 or 2 or 10 points. It depends on how hard the question is. I will tell you, you obtain how many points. Okay? Then I will calculate how many points you earn after our class. Alright? And if nobody want to answer, I will click this one. If there's no volunteer, I will regularly pick up 1 student. And if you cannot answer my question, I will take your point off. You will, yes. Okay. You can become a hero to answer my question to earn more points. If I pick up you and you fail the question, I will check your points out, okay? So, that's it, that's again. Yeah? No, it's fine. And you are protected. You don't need to answer. If I pick up you raise your hand, you try your best, then you are protected. I will not take your point off. Okay? So there are more things to get. It's more challenge. And please check your point. Okay, so this is a total which this score will map to your 30% of your final score will map according to this score. If you are earning more points here, which means for that 30% you have a higher score than other people. If you are very low here, maybe you earn 0 score. Yeah, after all. Alright? Okay, this is a way I encourage you to learn more. You are not supposed to just sit there and listen. You need to participate in this class to understand this class. After class, you need to watch your video, you need to read your book. I will give you more hints. I'm very welcome to help you and to discuss with you. Okay? This is how we learn, not only in this class. Okay? So, now it's time to review a little bit. What did we learn so far in our class? So, Maxwell's equations. We have these 4 equations. This is what we spend like 2 to 3 weeks to tell you what they are for those Maxwell's equation. For more details, maybe you can read chapter 1.2. Okay? You have books, right? And after that, it's pretty cold. So in 1.3, you learn, use these 2 equations, you can obtain that the normal direction of B2 minus B1 will equals to rho divided by the area, which is the charge density, charge divided by the area. Yes. And for this equation, you earn B2 minus B1 equals to 0. Those are from the Gauss's law. And for this, the first and the second equation, you learn and cross B E. First one is E. Minus E1 equals to minus M. If it's not time variable, so we don't have this part. And we have this term H2 minus H1 equals to J. Okay? And if in our textbook you may see something different because you see this one cross N, right? In your book, use this one because they took the minus away. Yes. Okay, my first question is, okay, you can raise your hand. So these four equations are, raise your hand, okay. Yes, good, 2 points. Okay, those are easy. This is an easy question, boundary condition question. But you can still raise your hand because this is just only 2 points, okay. So those four equations are boundary conditions. And this is in 1.3. Okay. And last week, I need more space because I will talk about last week. It's more difficult things. So I will take the first equation I will use the first equation here. I remember we did this last week, but I still want to do that with you guys. Okay, now comes the question. So for this part is showing in the chapter 1.4, and the first thing we are going to do is we take another curl. Then what happened? Anyone? Okay, we do. I will not do that for everyone, but I will ask one step by one step. If I take another curl, anyone raise your hand? No? Anyone? Okay. Okay, come here. Show me. Yes. Yeah. You are not going to sit there. Just sit there. You just take a step and I will ask the rest to others. So what will we do for this one? Okay. B equals to mu h. Oh, wait a moment. This one is a vector and this one is a scalar. Okay, so first thing you want to do is, okay, that's good. You earn, this one can earn, okay, 3 points. Remember for me and I will take. Okay, so you change first you change the B to mu H. Because of this relationship. So, B equals to mu H and D equals to epsilon E. This is the most important thing for today. We will discuss this one, but we didn't tell you too much. I just tell you, remember this relationship between B and H and the D and the E. This is about the materials. Okay. So, but you still didn't answer my question. My question is, if I take the curl, you just change H to B, right? If I take the curl here, that means for this term, I will also take the curl, right? I will take a curl to both of them. And for that one, I will have a condition. What is that condition? Anyone? Okay. M equals to 0 because no source. Very good. 2 point more. Okay, 2 more point. Now you have 4. Because there's no source, and also this one does not exist. So your result is this one, right? So you can write down. I want to write down more clearly. So this one become minus j omega mu times the curl of H. Then, what is the curl of H? Anyone? Raise your hand. Yeah, the same question last week, right? Yeah, show me, just show me. Okay, 2 points. This is an easy question. Okay, just circle it. Circle it. Yes. Okay. So this one equals to minus j omega mu times the curl H is j omega d. 2 points. Okay. Just, you should tell me later. Plus j. Okay, now it's important. Listen carefully. I tell you if there is no source, right? But if there is source, if there is current on it, if that is a conductor, if that is a current on it, what happened? You should consider this. And this one, J equals to conductivity times E. This is an important part we haven't discussed yet. If you consider this equation, you are talking about a lossy case, which is our real world. This means lossy. This is new. This is only for today. Okay, this is not preview. This is new. Okay? Did you take a picture, take a note? Okay, because I will erase it. Okay, because this is the most important thing. This is the condition new we are trying to discuss today. This is something. But so far, we discussed last week, we used the lossless case. And there is no source, and this is lossless. So what happened? First, don't have this time. This is last week. What happened last week? Okay? And What is D? D is, okay, no question, because it's also easy. I know you want to answer. D is epsilon E. So this one will equals to minus J omega mu times J omega epsilon E. Right? And you can have J times J equals minus 1 and times minus 1, so cancel out. And you obtain omega squared times mu epsilon E. Yes? Because for this term, there is a vector identity. Because you know this one equals to 0 because there is no source, so you can obtain this term become minus Laplace E for the left part, left side, okay? For this one, you take 2 curl. If the divergence of D is 0 for the case no source, you can change the left part to this one, okay? So what can you obtain? What can we obtain? So our result is this one equals to there are 2 questions here. First, what is this equation? Raise your hand. Anyone? What is this equation? Oh, question. No, I will call somebody. Anyone want to give me the name of this equation? Anyone?
Wave equation.
Yes, wave equation. 2 points. This is the easy equation. Okay. This is a wave equation. How about, can anyone tell me what is this? Raise your hand. Are you sure? Is this K?
K squared.
Yes. Okay, 2 points. But you are, okay. K squared. So, you can change this one. Okay. Can anyone tell me what is K? What is this his name? Raise your hands. Okay.
Propagation constant.
Propagation constant. Yeah. What else? 2 points. Okay. Yeah. Yeah.
Lossless.
Huh?
Lossless.
Lossless is a condition. I mean, what is the name of K? The first name is propagation constant. Skyson, do you want to answer? Huh? Phase constant. Okay, 2 more points. And the last name? Yeah. You answered already. Do you? Wave number. That's good. Okay. There, K is very important. Actually, it's not K important. Beta is important. But in here, K is very complicated. The relationship between K and beta is very complex. You can check my note on the website. There are many things talking about that. There are also K beta figure. K and beta is very complicated. But here, you guys are lucky. For a TEM wave, beta equals to K. So nothing you need to worry about, okay? nothing you need to worry about this easiest case. Because k equals to beta, the name of k is wave number. The name of b, beta, they have many names. The phase constants or beta is also, you can tell people this is the propagation constant. But this is only purely imaginary part because there's no loss. We will discuss this later. If k and beta, they are the same, it is easy. Okay. If it is a waveguide, k is not beta. If for the microstrip line, you guys are very familiar with k is not beta actually. You are doing microstrip line, no. You cannot say k equals to beta. Only coaxial cable k equals to beta. Okay, we will discuss this more, or maybe we will discuss this if you are a graduate student. You want to do more research, we will discuss more. But for you guys, we are very kind. Give you very simple question. That what if k is a propagation constant, and k is a wave number, and k is also the phase constant. Okay? Okay. Actually, we obtain this equation. I try to solve E, right? So anyone can tell me what is E field looks like? Anyone raise your hand? This is a hard question. If you raise your hand, you write down your equation. I will ask you more questions, so this will be a 5-point question. Anyone? Okay, come on. Write down, and I will ask you a question. Or maybe you can answer my question before I ask you. What is the condition for that equation? You should tell me. I want you write down what is E. What you solve this equation, you obtain what is E, right? Tell me what is E. This is general form, not the equation I solved from here. I want the equation. This is tell us nothing because Ex is a function. That's it. I want you to show me in what condition, if that is, and then you can have an equation looks like. This is a general form of all the E, and the Ex is a function of the x direction E field. But I want more. Tell me more. Yes. Okay, you can write down completely. If you write down this way, I give you 2 points. But this is not the answer I expect. I want more. You can still write down it. Okay, thank you. This is a general form of the E field. You have the X, Y, Z, right? If, okay, the question I will ask you. If E is only this part for X direction, and then you remember your picture, right? If this is Z direction, and this is X direction, your E fields looks like this one, and this is a plane wave. All the components the function only change with z. If z the same, the answer the same. Okay? If your function only change with z or time, so this is a function z and time. Okay? What is yes? Anyone? Now is. Do you want to answer? You just copy it. Still 5 points because it's more complicated. Yeah. Only you raise it. You are trying to save people, right? Because if you don't answer, then maybe someone will suffer. Wrong place, man. Dude, it's wrong place. What is gamma? You copy wrong equation. There is no gamma so far. Gamma, I will introduce gamma later. Wrong place. You just change gamma to k, but that is not correct. It's similar, but I will give you 2 points, okay? 2 points. You obtain 2 points. Close. But I want my answer. Okay, 2 points. This is okay. Almost. I will explain this one. Try to explain, try to understand. Change. 2, I give you 2 points. You are close. You know what I want. But not the perfect answer. Yeah. This actually the next part I want. Right now, okay, I give you 5 points if you write down this form as well. Hey, don't go, come. I want also a phaser form. Thank you. Yeah, okay, of course. Do you know where the omega t come from? Why we have omega t here, but we don't have omega t here? Okay, you still obtain 5 points. Okay, it's 90% right. Okay, 5. You got 5. Okay, there are more details. Anyone want to say more complete to make it more completely? Anyone? There are some things still wrong. Anyone see what I want? Do you want to show me? He is more right. Yes, but for you find something, but not exactly. I give you one point. But do you want to try? Do you want to try? This is hard, so no. Okay, I give you 1 point. Now you 9, right? Okay. Anyone? This is not correct. Who want to answer me? Come. This is a hard question because you need to understand very clearly. Make it right, please. Write down. Anyone haven't answered a question yet? Matt and you guys don't want to answer a question? Try it. On your point, test the class. Yeah. Yes. You can get. I give you 5 points. 5 points. This is a key, but you guys should do that very carefully. Okay. Okay. Let me show you. If you want to solve this equation, if E is a plane wave in this direction, you solve the equation E equals to EX, right, like you said. You try to solve this one according to Laplace, because there are two, this is a PDE, second order PDE. You will obtain EX equals to, this is not quite, but you just put it there, okay? I write down the correct answer. Equals E plus times cosine, okay? This is minus KZ, okay? Plus E minus cosine positive KZ. But this is only the function of Z. That's why you need to consider about the time. Once you consider about the time, you times your equation to exponential minus KZ. This is a solution for the PDE positive KZ, okay? This is no time. So you need to consider the time, you put the time part in there, then you need to multiply to exponential Z. This is JKZ, and then this J omega T, because you consider time now, but this is a time harmonic. So you don't consider this at the beginning, you do this after that. After that, you obtain E equals to exponential J omega T minus KZ plus E negative times J omega T plus KZ. Okay? And if you want to say, because this one is only this part, so the total E will become this one multiplied to this is the complete and the correct one. Okay? So what is this one? Raise your hand. 2 points. Raise your hand. Huh? Okay. Wait. Yeah. You remind me. Because this is a phase form. I will ask you that later. Okay. This is a phase form. You use the Euler equation. This is a complex because there are J here, right? You can write down like times cosine omega T minus KZ plus E minus cosine omega t plus kz, and you want to make it perfect because this is a vector, you need to write it down. Okay, this is only the real part of that. You take the real part. And you got this equation. Okay, so my question is, what is this one? Phase, 2 points. This is the phase, the theta, the phase. Okay? Okay. If you want to do the circuit design in your project, you say E equals to 90 degree. You want to do that sometimes, right? This one looks like this actually it is beta, and this is L. Beta L equals to 90 degree equals to pi over 2. And then you put the beta here, you know how long your line is. This is theta, and this is phase. They are totally the same. But now we are discussing the wave. In your circuit design, you discuss voltage and current, but they are the same thing. Because the voltage and current also looks like a cosine function. That is phase. Okay? Okay, so far I'm reviewing. So there's no new thing except that one I just erased. I just erased something. Okay. You tell me for a positive wave, omega t minus k z, it is phase, right? Now we want to think about the velocity of phase. How do we define the velocity of phase? How fast it is? We fix a point and we say, okay, go and stop. We try to measure if this one is here, then after some time going to this part, and this is delta z, because z is the position, right? And the t is time. Okay. If there is a wave, we try to check what is the velocity of this point to this point. The definition of that is, anyone, 2 points? Raise your hand, please.
Wavelength.
Huh?
Wavelength.
Wavelength, not the physical distance. I mean the speed. What kind of velocity it is? What velocity? This is. Raise your hand if you want to answer. No. This is phase, right? Yeah, it's easy to put. So I'm giving you a clue about the definition of phase velocity. This is the definition of phase velocity. Okay. If your beta equals to k, you don't need to consider many things, as I said. For more complicated transmission line, sometimes beta is not k, and also beta will change with frequency. If this happened, for your wave, the same transmission line, if you have different, if your beta is depending on frequency. Your velocity of your phase will change according to different frequency. I'm talking about more other than this chapter. This is what happened for a waveguide, what happened for your microstrip line. You are talking about a dispersion, dispersive. Different frequency, they have different beta, which means their speed is different for different frequency. So that is more complicated. For that case, you cannot see VP, you should see VG. This is the group velocity. If you want to design a filter, you should show also the group velocity, not only the phase velocity. Okay, just keep in mind. You just remember this one, but this is not discussed in chapter 1.4, not yet. But I just give you something will happen in the future. Okay? For your case, it's an easy case, TEM case. You just consider VP. How can we obtain VP? We try to divide this one and then equals to 0. We try to differentiate this one to time, and then this one equals to 0. Okay? And because this one will become omega only minus your k times dz dt equals to 0. Okay? And this one is our velocity. Okay? Which means Vp equals to omega over k. Okay? So, next question. So, what is k? Anyone? Yeah. Raise your hand. 2 points. Because it's on the board. Okay? Raise your hand. Right?
So 整 K 是
Yeah, what is K? Give me the equation. K equals to
omega，然后
omega times
跟
square root of mu epsilon. Okay? So omega cancel out. So phase velocity is the square root of mu epsilon. Okay? Epsilon and the mu, they are the parameters of material. If it is air, you use epsilon equals to is that correct? And the mu 0 equals to, right? And last week, you try to put this equation here and obtain C is 3 times 10 to the power 8 speed of light. But if your material is different, then you use different epsilon and different mu here, okay? This is what we do, what we did last week. We derive Vp, this one, and also mu epsilon. Phase velocity. Okay? Furthermore, I need a good eraser. We use this equation, the first equation. We try to obtain the ratio between E field and H field, which is Anyone? We try to get relationship. Let me write down this one. If my E field is Ex and only the function of t and the z times x, right? I can obtain my H field equals to Hy is t and z also in y direction, okay? I want to know the ratio between Hy and Ex. I didn't write down this one, but you already know, okay? This they have only the t and the z component for that. Will equals to eta. So what is eta? Anyone raise your hand? Yes, wave impedance, 2 points. How many points you obtained so far? 11. Okay, that's good. We try to derive this one. Is that too fast? Because I am trying to review everything for the previous all of the previous weeks. Okay, this is what you are supposed to learn. And we are now in chapter 1.4. You can check your book. We are doing the same thing. Okay? So, this one, which equation we will use? First one. We use the first equation, right? So, we try to derive it. Will equals to minus j omega mu h. This is the last part in our last week. Okay, so now it's time to take a break. So let's take a break and come here and I will give you points. Okay, come here if you obtain